video will help assist those of you that were not with me in class still be able to understand what's going on with this data, and also collect it if you do not have the materials at home to set up the apparatus to measure the balloon or a balloon at all. So what we're going to be doing in this investigation is we're going to be measuring the vital capacity of my lungs. We'll be doing 3 trials of that, getting an average. We'll be looking at the expiratory reserve, same thing. The tidal volume, same thing. And then we'll be plugging in those values into this graph and then using that to answer questions that follow. So the first one that we're going to be doing is we're going to be looking at vital capacity. So it says to stretch the balloon several times. I'm doing that right now. We have to take a deep breath and then exhale all of the air that I can into the lungs and then measure the balloon essentially. And that's going to measure the vital capacity. Going back up, you should recall that vital capacity in green here is all of the lungs after a max inhale and a max exhale. So this is what we're going to be measuring for my lungs. So let's switch over to my apparatus. I have marked out a scale here in centimeters, starting at 0 right up against this board, and I'm going to hold my balloon up to it. I can use a straight edge to kind of measure the size of that balloon in centimeters. So balloon is nice and stretched out here. Okay, can't get any more out. That takes a little bit out of you, I'll tell you what. So I can now measure, and I can see that that is right at about 21 centimeters. So now I can take that data, go back to my table here and plug in 21 centimeters. And you are welcome to use that number yourself. We can then repeat this 2 more times for the remaining measurements, then come up with our average. So let's go to our second trial and our third trial. And for these ones, I'll be telling you the numbers, but I'm not going to be putting them into this chart. I'll let you kind of do that. So we'll go back right here. Got to get a couple more. Let's see if I can get more than 21 centimeters. All right, so we'll measure that, and that is about 21 centimeters again. All right, one more time. Let's see if I can hopefully not get 20. We'll see if I can get 22 this time. That's might be tough to do. All right. I did not do it. I got 21 again. So, hey, consistent if nothing else, right? I got 21 again. So, on the data table, you would have 21 for all 3 trials. You can then get your average, which is going to be 21. And now we need to use the graph below to figure out the volume of this balloon. So I am given my diameter, I need to figure out the volume. And when we use this graph, we are looking at the diameter of the balloon, which we were given. I had 21. And we can then use that to measure the volume of the air in that balloon. And we do have to understand that this is an approximation, not an exact. So I had 21. I can go up and measure that line up, and it crosses right about here. And then I can come over this way to get my volume, which looks like it is about 4,500 cubic centimeters of air in that balloon. So I can come back to my graph and I can plug in 4,500 cm cubed. You can leave it like that. I'd be okay with that, or you can superscript it if you'd like. But repeat the same for the remaining measurements. You'll be using that graph the exact same way to do the expiratory reserve in the tidal volume, which we'll go through and do here in just a moment, starting with the expiratory reserve. For the sake of, I guess, just logic, it almost seems like we should do tidal volume before expiratory reserve. So we're going to do that. Tidal volume, going back up to our graph just to kind of recap on what it is. Tidal volume, resting tidal volume, same thing. This would be about the amount of air that we inhale and exhale when you're sitting at your desk and just breathing normally. Tidal volume is normal breathing rate, which according to this graph is about 500 milliliters. We'll see what we come up with. So I'm going to just take a normal breath and inhale that or exhale that into my balloon. Again, got to do 3 measurements. This is a tough one to do because you have to put a little bit of force when you're blowing air into the balloon, and it's tough to get an accurate normal breath out, normal exhalation when you actually have to push a little bit to get the air, into the balloon. So we'll see what we can do the best we can. So normal breath in. Normal breath out. As you can see, the balloon is considerably smaller, as it should be, simply due to not pushing all the air out, and I'm certainly not taking a max inhale. So get my straight edge here. It looks like the measurement here is 11.5 centimeters. So I can plug in again for my data here. 11.5 cm. You can then take that number to the graph below to get the volume. You should know how to do that at this point. Let's get our last 2 measurements here. So again, normal breath in, normal breath out. All right. This one is about 12 centimeters. So 11.5 and 12, that's pretty consistent. Let's get our last one. There's our last one, and this one is looking to be 11. So we have 11 centimeters. Now you can take that data, you can record it, you can get the volume, but I'm going to roll straight to the expiratory reserve. The expiratory reserve, this is, as you can see based on this graph, it's right here in yellow. We have a normal breathing pattern, tidal volume, so normal breath in, normal breath out. I'm right back down at the bottom of tidal volume. So the expiratory reserve is, after I do a normal exhale, I would then force as much air out of my lungs as possible, and that volume is our expiratory reserve. So that's what we're going to be checking out right here for expiratory reserve. So normal breath in. Normal exhale. And then force out as much air after a normal exhale. Looks like my first number, about 15 centimeters. You can go ahead and record that, 15 centimeters. Trial 2, normal breath in, normal breath out. Whew. And let's see how much we got that time. That time was 13 centimeters, so considerably less than the first trial. Kind of reiterates the point of multiple measurements, multiple trials. One last time. And looks like this one is it's about 14 centimeters, about 14 centimeters. So you now have the 3 trials from me for this data as well. You can then get the volume, and then you have the information that you need to answer the analysis questions that follow. Looks like there's 7 of those. If you have any questions, certainly reach out to me. Let me know what's up, and we'll get you squared up so that you're good to go.